Hello and welcome again to Astronomy Made Easy. Today we're going to quickly learn how stars form, what makes them burn, and how they die. Now here's a picture of the Eagle Nebula. So in a nutshell, star formation occurs within nebulae such as these when gases condense together through gravity. The gravity then creates nuclear fusion, and that's what makes a star burn. Then as the star runs out of fuel for nuclear fusion, it dies. So we're going to look at some diagrams, and hopefully it'll make it a bit easier to understand. So gases condensing through the force of gravity should be easy enough to understand. We all get the fact that gravity pulls things together. So essentially gravity is pulling gases together to start the formation of a star. So we're going to go ahead and look at nuclear fusion. But first we need to understand a few basic points. Now hydrogen and helium make up approximately 98% of the ordinary matter in our universe, which makes them obviously the most abundant elements. So in the early formation of stars, you have mostly hydrogen and then helium atoms. So here's a picture of the structure of hydrogen and helium atoms. I'm leaving out the neutrons to avoid complicating it. Now the protons in the nucleus, the blue things there, have a positive charge, and the electrons are the red ones, and they have a negative charge. So the atoms will naturally try to repel one another because they each have a negative charge in their shell. However, inside the core of a star, the force of gravity becomes so strong inside that core that the two hydrogen atoms will be pushed so hard together that they will actually merge together and become helium. Now what follows is an enormous release of energy. So to give you a rough idea, our sun, which is relatively small compared to other stars, puts out 3.8 times 10 to the 26 joules per second. And in comparison, the Quad Cities nuclear reactor in Illinois can put out 867 million joules per second at max capacity. So I've written these out long form for you so you can actually see the difference. And then here is an energy output comparison of atomic bombs between how much the sun puts out a second, so you can see just what a crazy amount of energy our sun puts out. Now that energy output from the core of the star, due to the fusion process, creates an equilibrium that supports the star from collapsing under gravity. So you have inside the core, the fusion process creates the reactions, and then the energy starts pushing out. But you also have this collapse from gravity that's pushing in. So you have this kind of back and forth struggle between gravity and nuclear fusion, and that's what keeps a star burning and keeps a star alive. So essentially a star is just an enormous nuclear fusion reactor. Then the star will continue to fuse hydrogen into helium. The helium are heavier elements than the hydrogen, so the helium floats down to the core. Then the helium will fuse together, two of helium atoms will fuse together into carbon, and carbon into neon, then neon into oxygen, and oxygen into silicon, and finally we have silicon going into iron. And it will end up creating this kind of onion layer star that you can see here in this diagram. Now once the core of a star becomes iron, the fusion process consumes energy rather than produces it. So basically you have the star running out of fuel. So the core can no longer support itself under gravity, and the gravity just makes the whole star collapse onto itself, and it will die in a number of different ways, and that completely depends on the size of the star, and I will go all over that in another video that I'll be putting out soon. So I hope this explains it for you, and as always, feel free to comment or ask questions below. Thanks for watching, and have a good day.